Hello everybody, Bill Sky the COBOL guy, and this is another video in the series of COBOL programming videos that I've been doing. And today what we're going to do is we're going to look at arrays, or as COBOL and IBM call them, tables. That's kind of funny because when I started getting into C and C++ and Java and they called them arrays, I always called them tables, and students looked at me like I was crazy. So did some developers I was working with. But that's what arrays were back before these newer languages. They were called tables. So you might hear me use those terms back and forth, but tables is equal to arrays and arrays is equal to tables. Now if you don't know what an array is, really quickly, an array is simply a contiguous set of variables or values identified by a single variable name. By contiguous, I mean in memory, each value is right next to each of to the first one. So the second one is right next to the first one in memory, the third one is right next to the second one, the fourth one is right next to the third one. Now COBOL really makes creating arrays or tables very easy and very flexible. So I think the best way to do this is to get down and do some coding, and we're even going to do some procedure division stuff where we're going to process the arrays because it's the best way to illustrate it. So let's get coding. Okay, so we're going to do this on Windows this time. And I downloaded my COBOL template and I put it in documents under my COBOL projects, and there's my COBOL template. Now I'll put another link to that in the description of this video. And I'm just going to right click on it. I'm going to go to show more options, 7-zip, my favorite zip program, and just extract here. And then I'm going to rename it, and I'm going to call this arrays 2D for two-dimensional arrays. Now we are going to talk about this is a one-dimensional array. So we're going to talk about one-dimensional arrays first, and then we're going to talk about two-dimensional arrays right after that. So let's go into that, and I have the Genie editor loaded or installed, and we can start messing around with our code. So let's create a very simple one-dimensional array. And just so you can see how it imitates other languages, as a comment, I'm going to put a comment here. I'm going to say, let's call it, I don't know, one dim array. And if we're going to do it as in a C program, I'm going to say float one dim array square brackets 10. So this is how you would do it in C, C++, probably even Java, although I haven't coded in Java for a little while. But I'm sure that's how it's done. And what this does is it creates 10 floating point variables or 10 floating point values in memory starting at the address of one dim array. And notice in C and C++ and Java, you use square brackets to specify the size of the array. Now, how would you do this, or the table? Now, how would you do this in COBOL? Well, in COBOL, and I'm just going to make it a 77 for now, I'm going to call this one dim array. And instead of having square brackets, I'm going to say occurs 10 times. And then I have to give it the data value, the data type. So I'm going to say usage is comp1. And so that is a one-dimensional floating point array. Now, because I'm on Windows, we're going to have to do things a little bit different. I'm going to go ahead and make a custom type. I'm going to call it win. And what did I do wrong here? Oh, I forgot a period somewhere. I'm almost sure I did. Okay, line 21, let's see where the problem is. Oh, I made that into a comment. Let's make sure. Oh, my Genie editor is not set up correctly. I've got tabs in there. So what I'm going to do is I'm going to go into Tools, or I should say Edit, Preferences, Editor, Indentation, make it all spaces, and say Apply and OK. And then I'm going to go to Project, Apply Default, and now I should be able to do tabs, which are actually spaces. So let's go ahead and now build this. And it built just fine. So this created an array of 10 floating point numbers starting at the address of one dim array. Now let's go ahead and process this. Let's do something with it. So I'm going to come down here and I'm going to use something new in the procedure division. So I'm inside the procedure division and I'm going to use a thing called perform. So I'm going to say perform until, and let's use the WS counter variable I have there, is greater than 10. And then I'm going to say end perform with a period. Now perform is like a loop. In this case, it's just like a while loop. So it would be while WS counter is less than or equal to 10. So we're just going to, that's the format that may be the first time you've ever seen that. And now within there, and I have to make sure, here's my counter. This is the counter right here that we're going to use to subscript the array. Okay, so I'm going to say display, and I'm going to give it the one dim array. Now instead of square brackets, use a open parenthesis, and you say WS counter. And then I have to add one, so I'm going to say add one to WS counter. And notice I didn't put a period at the end of any of those statements because they're inside of a perform. So let's go ahead and build that. All right, looks good. Now I'm going to go to my terminal and I'm going to run it. Oh, I typed it in wrong. Let's see. It looks like I got a problem here. Yep. I'm really glad that this happened. This says that my subscript for one dim array is out of bounds. It has a value of 0. Why? Because COBOL arrays or COBOL tables, they begin at 1. Let's go ahead and build that. And now it works fine. Okay, now there's just strange data in there. I mean, right now it's all zeros. Let's go ahead and create another perform. So I'm going to go ahead and copy this. And I'm going to say move WS counter to So what we're going to do first is we're going to populate it with just an integer value, and then we're going to go ahead and print it. Now, it might not be a bad idea is to we'll go ahead and just put a little comment there, a little display, so it knows what I'm doing. And then I'm going to say displaying. All right, let's go ahead and build it. All right, let's run it. Okay, so I'm not sure why it, oh, here it is right here. Okay, so it says setting the values in the array. So the program sets those values, and then it goes and does another perform, which is displaying the values in the array. And you can see the values are 1, 2, 3, 4, 5, 7, 8, 9, 10. Okay, so that's a very simple way of setting up an array or a table in COBOL. Now, there's many ways that you can do this. One of the best ways, though, is, I don't know if you've noticed, but I had to use a variable here called WS counter as the subscript for the array. And the subscript is what is the index that I want to look at in the array. Well, there's another way of doing it to where you don't have to do that, and it's actually more efficient to do it this way. I'm going to say, when I create my one-dimensional array, I'm going to say indexed by, I don't know, I'm going to give it a name, ODA index. Now what that does is it actually creates a variable that you can use when you're inside of the perform to process it. and it uses this variable only for indexing or only for accessing the values inside of the array. Now, if you do that, you can also change the perform. I'm going to say perform, and I'm going to use the varying keyword. So I'm going to say perform varying ODA index from 1 by 1. Now, if you do that, we no longer need the WS counter until ODA index is greater than 10. We no longer need this here. We need the ODA index. And we no longer have to add 1 to WS counter. So I think that's pretty cool, is that it's all part of a single statement. And I went and I changed the perform there. Now we no longer need the move to WS counter. We no longer need it there. So our code has actually gotten smaller line-wise. I don't know if the number of characters is the same or not. And let's go ahead and copy this over to here. Now in a project like this, you're not going to see a big performance difference. But it's certainly worth, well, it says displaying, let's make sure I did this right. Oh, yep. So I'm moving WS counter to 1 dim array at that location. I need to change that as well to ODA index so we can actually see some values. The code worked, but not the way we wanted it to work. There we go. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, great. So that is two ways. You can set up an array or a table with a value and then use a subscript, or you can set it up with an index and then use that index to process the table. The second way is actually probably the most accepted way of doing it. It's faster. It's all it's all built in. It's really kind of nice. Okay, the next thing I would like to do is I would like to create an array that is variable in size. It could get larger or smaller as the program executes. So let's go ahead and do that here. So I'm going to create another one called 1 dim array v for variable, and I'm going to say occurs 1 to 99 times depending on I don't know, we got to have some kind of a variable here, so I'm going to say array size, and I'm going to say indexed by ODAV index usage is comp1. Now, if you're not sure what this usage is comp1 thing, you might want to take a look at the video before this one about data types. Comp1 is basically just a floating point number. Okay, so let's go ahead and build it and make sure everything's okay. All right, let's see what we got here. Oh, I know what we got. We forgot to define array size. We forgot to define this. Now, this can be a constant. Most of the time, it's not. Most of the time, it is a variable. So, array size. I don't know. What do we want to make this? Pick 99. Value 0. All right, there we go. So depending upon the size or the value that's inside of array size is going to tell you just how large or small your array can be. Now let's actually do something with this. I'm actually going to ask the user to tell me how big of an array they want. So after I process this down here, I'm going to do this. I'm going to say display how large would you like the array to be? And I believe it's with no advancing. Now, what the display with no advancing means is it doesn't go to the next line in the display. It actually just stays on that line. Okay, so I'm going to say except And what was the name of our variable here? Array size. So let's go ahead and accept array size. Okay, now that I put a value into array size, the array is that big. The table is going to be that big. So what I'm going to do is I'm going to just copy and paste that display. Actually, let's go ahead and copy and display. Let's do both. Let's set the values. Okay, so we're not going to use ODA index. We have to, because that was for our first one-dimensional array, we have to use ODA v index. And we're going to do that over here as well. But instead of greater than 10, we're going to say array size. We have to change all of our ODA indexes to ODA v. Now you would have to do this in any language. Okay, let's see if we've got, if it looks good. Looks pretty good. Let's build it. Great. Let's run it. Okay, how large would you like the array to be? Now, if you didn't say with no advancing on the display, it would actually take you to the line below that prompt. So I'm just going to put a 5, and it put 5 values in there. I'm going to say 50. Now, a little bit of a problem here. 50 is, let's see, it says setting values in the array. It says it died at 11. Oops, what happened? Yep, I forgot to change the value of the array here. So it was 1 dim array v. Yep, so I forgot some things in my code. I got an error. So I should put the run. So I was using the first one-dimensional array instead of the second variable sized array. And the compiler didn't tell me anything. Okay, so let's go ahead and do 50. And it did it. So now that I'm using the correct array. Let's do it again. I'm going to say, well, I don't know, 22. And it did it correctly again. Now to prove my point here, whether or not it's as big as it, if it changes size dynamically, I'm going to go ahead and I'm going to put this except down here. So we're going to make the array larger or smaller. And I'm just going to copy all of this code down here. How large would you like to? Yeah, let's so we can test it to be bigger or smaller. Okay, let's build it. All right, let's run it. So the first time, I'm going to make it 5 in size. The second time, I'm going to make it 10 in size. So it got bigger. The first time, let's make it 10 in size, and I'm going to make it 4 in size. Now it got smaller. So the COBOL runtime system, the COBOL, the code generated will actually make the array bigger or smaller. Or so it seems. I'm not really sure how GNU COBOL does it. For that matter, I'm not really sure how IBM COBOL does it underneath the covers as well, but it seems to work that way. So again, that is a variable sized array. In this case, we called it 1 dim array v. It occurred 1 to 99 times. Let's do a little test here. I'm going to put 200. And well, it didn't, well, it only took 20. Boy, that's interesting. I typed 200, but why did it only take 20? Well, let's go back to our code. The reason it only took 20 was because array size is a pick 99. So when I typed 200, it just dropped off the last 0. That's actually a way to protect the size of your array. But let's go ahead and put 999 there. And let's see if we can get the program to die. Okay, so 200. Now remember, it said occurs 1 to 99. I'm going to put 200 in there, and we got an array out of bounds. So 200 is way too big. Now, we're not catching any of these errors just yet. So the program just died just like a Python would before, or any program would. But at least it gives you more information in the COBOL when it dies. Okay, now there's one last thing that I want to talk about here when it comes to arrays in COBOL, and that's the case. In this case, we're just using simple floating point numbers in an array. What if I wanted to put a structure in there? Well, it's really nice how this works out. I'm just going to call this one, I'm going to use 01 instead of 77, struct array, and I'm going to say that occurs 10 times indexed by SA index. Now I'm going to put a period there, and I'm not going to put any data type there. What I'm going to do is I'm going to say 05, and I don't know, let's say full name, and let's say pick x32. I'm going to say 05. Let's spell this correctly. Age, let's make that pick 999. And then 05, weight, let's make that usage is comp1. And let's go ahead and build it. Make sure we didn't type anything strange there. All right, looks good. So what we have now is we kind of have a two-dimensional array here, right? We've got the struct array 10 times, and each row has 3 columns: the full name, the age, and the weight. And so you can access that data. It's not quite like a two-dimensional array in other languages, but you can. Let's take a look at that. So let's go ahead and process that data. So what I'm going to do is I'm going to go down here to the bottom. Let's go to the top. Okay, and I'm going to say, I don't know, let's say move test name to full name in struct array 1. So that will move full name into the first row of my structure array. Or actually, let's move test name into that variable. I want to move 32 to age in struct array of 1. Now this could be a counter. You could be asking the user to type this data in, which wouldn't be a bad exercise to do after this. So just do a perform and just have the user type in a bunch of data. Okay, so I'm going to move 180. I need a diet. To weight in struct array 1. So that's putting data into the first row of the array. So let's go ahead and build that, make sure it's okay. Looks like it built okay. All right, now let's go ahead and display it. So I'm going to say display full name 1. Let's put a comma there. Age 1. And I'll talk about the syntax in just a moment. And let's run it. Well, let's build it first and let's run it. Okay, so as you see here, the program began hello world. I set the values in the first row of the array to be test name 32 and 180. And you can see right here that there's test name. Now, why is it so big? Because we made it 32 bytes. We could always justify it, but it's 32 bytes. We've got the age, 32, and we've got the weight, 180. Now let's go back to the code, and let's take a look at the difference in the way I coded it here. Notice in this case, I said move test name to full name in struct array 1. Now why did I do it that way? Well, there might be another structure that has the word full name in it, or the variable full name in it. There might be a 77 variable that says full name. So you can have the same variable name inside of structures, inside of 01s, 05s, 10s, and 15 level variables. And as long as you use the in parent, if we go back here, there's the parent of full name. As long as you use in, the compiler will not become confused. We did the same thing with age. We did the same thing with weight. However, on the display, I did not use the instruct array 1, parentheses 1. I used full name 1, age 1, weight 1, simply because I know that those variables are not going to be used in this program again, or aren't right now, so I don't have to use the instruct array. However, if full name is going to be, let's say age is going to be used in another structure, I could have done it that way. So you can mix and match them. You don't have to do them the same way every time. All right, let's go ahead and build that, and I'll show you that. I'll go ahead and run it, and there it is. So it worked exactly the same. There's my test name, there's my age, and there is my weight. So I think it might be a good idea to mess around with this. It's pretty neat how it works. To mess around with it, maybe put a perform 10 times. Instead of doing a move, say accept full name instruct array. And we have to have some kind of a counter here. And I might want to actually say something like move 1 to WS counter. And then we have the same thing with weight. And then we're going to have another perform. Let's go ahead and set the counter to 1. Now again, I could use the index. I'm just using the subscript counter right now just to get it done quickly. And instead of 1, we're going to say WS counter. And then let's do the end perform. I think that might be it. All right, let's go ahead and build this. Yeah, I would have been amazed if I didn't have an error in there. Okay, so what does it say here? Perform statement not terminated by end perform. Well, that probably means I have a problem over here. This counter, WS counter. Oh, there it is. I have a period. Boy, I'm glad I'm making these mistakes. So the problem here is that I have a period right there. So again, the statements inside of perform, you cannot have a period at the end of those statements. I know, it's kind of weird, but that's how it works. Okay, now let's see what we got here. One status, make file. Oh, it says it cannot open output file main.exe, permission denied. That's a Windows problem. That's not a COBOL. That's not a Genie problem. That's a Windows problem. And the reason is because I'm still testing it in my terminal. So I'm going to press Control-C. I'm going to go ahead and build it again. And now the problem went away. Okay, so let's go ahead and run it. Hello world. Now remember, I didn't prompt the user for any data. So I'm going to say x11, y22, z33, a44, b55, c66. Huh. Oh, I think I have an infinite loop here. I never... Yeah, it's all, everything is being put into 1, so let's change this. Oh, and it's 10 times. So we'll say add 1 to WS counter. And let's just make it 3 times, just so we can test it better. And I forgot to add 1 in the display as well. All right, now we have to remember to end the program before we build it again. On Windows. On Linux, you don't have to do that, which I always thought was interesting. All right, let's run it again. Okay, A11, B22, C344. And there you go. So there's my A name. There's my age of 1 year old and 1 pound. So you can see how using that structure, you can ask the user. Now, what I would definitely do here, I would say something like display, please enter the full name. Do the same thing here and there. Enter the age. And then enter the weight. Oh, nope, I need to do the win. Oh, it's still running. I keep forgetting to do that. It's funny because I used to always get down on my students about doing that. Always end your program before you start making changes. All right, please enter the full name, Bill. The age, 32. Weight, 170. Sue, 29. 110. Carl, age is 63. 210. And you can see our data right there in the array or in the table. Okay, so that is an introduction to COBOL tables or arrays, one-dimensional arrays. There's going to be another video on two-dimensional arrays. It's going to be a pretty short video, but I wanted to separate them out. Hope to see it at that next video.